apply basic principles of fluid mechanics, heat and mass transfer to study problems that relate to water purification, and specifically the challenges of making water purification more accessible, so making it more sustainable and making it more energy efficient and making it ultimately cheaper. One of the main themes in my group that relates to energy production is the concept of using acoustics or sound waves as a mode of energy transduction, which basically means that we can create sound, very intense sound, from heat. And that sound is now a form of mechanical energy. I call it a virtual piston. And so it can do everything that a real piston can do. So imagine an internal combustion engine, a turbine, or any kind of mechanical contraption that we have all around us, but we replace all the mechanics with sound. So the sound wave mimics the thermodynamics of those devices, but it does it without any moving parts. So the simplicity and the lack of friction holds great promise for reducing costs and reducing wear and tear, and making this, in particular, a promising technology for developing countries. How does heat turn into sound? That is a very common question. And probably the most intuitive explanation is thunder and lightning. The lightning heats up the air considerably, and that heat translates into expansion. So that when the air expands dramatically because of the heating, that expansion is a disturbance that propagates through the air as sound, and we hear the rumbling sound, but it decays. So what we do in our devices is we continuously supply heat into the system. So now imagine a continuous lightning, which turns into a sound wave. We have functioning devices, we have proof of concept prototypes, we have patents. We're looking towards eventual commercialization. There are other groups in the world who do similar things, but the particular approach that we're taking is unique to us. And the potential breakthrough there is our ability to tap heat sources at relatively low temperatures. So imagine a solar collector that currently heats the water in your shower, in my shower, everybody's shower, but is able to generate these really intense sound waves and then in turn replace your refrigerator or replace your air conditioner. So now you have solar-driven cooling of your home space. GTEP is a great platform for me. It offers several unique opportunities. The main one is access to top students, without a doubt. Looking to the future, I think that I'd be really happy to see us at the point where our devices can become competitive with current technology. In particular, we look at third world countries, developing nations that are off-grid, don't have access to electricity, but on the other hand have a lot of heat, whether from burning wood, whether from the sun. And so our ability to provide them with what we take for granted, which is a small refrigerator to store medicine, or food, or a little bit of electricity to charge laptops, cell phones, and light up a house at night. I think that's a great challenge, and I hope that we can meet it.